We're going to look at what's called the end behavior of a function. And this idea is a very general function concept that can be useful. I'll try to explain why as we go along here. But this video, we're just going to define it and look at some examples. So first of all, what's the definition of end behavior? So the end behavior of a function describes what the function does as x approaches infinity and as x approaches negative infinity. Okay, so think about whenever x is really big, what happens to the function? And that could be a really big positive number or a really big negative number. Okay, so let's get right into some examples here. Describe the end behavior in a sentence. Okay, so I've got some graphs here that we'll use. And now we're not talking about how to figure out the end behavior. That's our goal eventually. For now, what we want to do is just be able to look at a graph and to describe its end behavior. All right, so we'll get comfortable with some terminology. So you notice this graph has arrows on the left end and the right end. That means that the behavior of that graph continues as indicated forever. So when we say x goes to infinity, when we say x goes to infinity, we're talking about going extremely to the right of the graph. If we say x is going to or approaching negative infinity, we're talking about x values going extremely to the left. And we can see what happens here. As x approaches positive infinity, this graph is going to keep going down forever. And it's going to go more and more down. So what's happening here is the y value is going to negative infinity. So as x goes to positive infinity, y approaches negative infinity. And so this is how we describe, if you wanted to label this, this is how we could describe the right end. You wouldn't have to label it that way. I'm just trying to be explicit in this video. So the right end is as x goes to infinity, y goes to negative infinity. The left end, as x keeps going to the left forever, this graph is going to keep going down. So on the left end, we could say as x goes to negative infinity, the y values here keep going down forever, going closer and closer to negative infinity as well. So as x goes to negative infinity, y also goes to negative infinity. So we've fully described the end behavior of this function, which consists of both the right end and the left end. Let's try another example. So we're describing the end behavior of this function. So again, we're looking at what happens as x goes to the right forever. So now we're looking at the right end of this graph. This graph keeps going right and up. So what we say here is as x goes to positive infinity, this is the right end of course, y goes to positive infinity as well because it's going up forever. Okay? If we look at the left end, as x goes to negative infinity, we can see that as this graph goes to the left forever, the y values are going down forever. So as x goes to negative infinity, y also goes to negative infinity. And so there we have fully described the end behavior. Let's try another. All right, let's look at the right end. On the right end, we can see that as x goes to positive infinity, y is going to keep growing forever, so y also goes to positive infinity. The left end is a little bit different this time. As x goes to negative infinity, as our graph goes to the left, sorry about my negative there, as x goes to negative infinity, y is not going up or down forever. Instead, what it's doing is it's getting infinitely close to this x-axis. So what is y getting close to? Well, y is getting closer and closer to 0, right? This is the y value of 0, okay? And so that would be enough to describe the end behavior. If you wanted to be even more explicit, we can see that y is getting close to 0 from the positive number side of the y-axis, the y values, right? These are all positive y values getting closer and closer to 0. So what we could say is y is approaching 0 from the positive side. So you could put a superscript of a plus here, and that would indicate it's getting close to 0 from the positive side, because it could be getting close to 0 from underneath, and that would be from the negative side. So this example is a little different. Let's do a couple more. All right, in this function, let's look at the right end behavior as x goes to positive infinity. Y is getting closer and closer and closer to 0 again, right? It's not going up or down, it's getting horizontal and getting closer and closer to 0. Now, of course, I'm making an assumption here, and I know a little bit about this function. You might think that this graph is going down forever, and that would be reasonable in this case. But I can see over here on the left, my graph is getting closer and closer and closer to the x-axis. So because I've developed this example, I'm telling you that on the right side, this graph is also going to keep getting closer and closer to the x-axis. So y is approaching 0 from the positive side because it's above the x-axis. It's above 0. On the left end behavior, as x goes to negative infinity, y is also approaching 0. If you want to be more explicit, it's getting closer and closer to 0 from the negative side because it's below 0 and getting closer to it. So we'd put a superscript of a negative there. All right, one more example and we'll be done with defining end behavior. Okay, so for this one, let's describe the right end behavior. And let's also look at the left end behavior, because I zoomed in on this one quite a bit so you can see what's happening here. You can see that on both ends, y is getting infinitely close to this value right here, right? It's getting infinitely close to this line, which is a y value of 1. So in both cases, as x goes to positive infinity, y is getting closer and closer to 1. And as x goes to negative infinity, y is also getting closer and closer to 1. If we want, and that would be fine for describing the end behavior. If we want to be more explicit, on the right end behavior, we can see that y is getting closer and closer to 1 from beneath 1. So we'd put a superscript of a negative here. That doesn't mean negative numbers, it means from below 1, from numbers smaller than 1. And on the left end behavior, y is getting closer and closer to 1 from above 1, so we put a superscript of plus. And that gives us an even more explicit description of the end behavior. So end behavior is significant because in reality, let me see if I can show you here. Let me bring up the graphing software I'm using. So here's that graph, okay? Let me cover up a lot of what's going on here. Let me zoom out. When you zoom out, so far you can see that the end behavior is basically all that you see. You have to zoom in pretty far here, if I can even line it up properly. Yeah, so I don't have the origin on the page. Here we go. Let me zoom in now. When you zoom out, you start to see that the end behavior is most of the graph, and in the middle here you might have different behaviors, but most of the graph is on the ends because it goes on forever that way. All right, we could take another example here, like this function here. The ends of this graph, you can see the right end is going up forever and the left end is going down forever. That's the majority of the graph. Or in this case, let's look at this one. I've got that one cut off on the end here. Let me take that off there. There we go. So the left end, you can see, is this horizontal line, and the right end goes up forever. So End behavior is significant because it describes most of a graph. Now, not all functions are well behaved on the ends, so we're not going to look at those. But just to give you an example, if you're familiar, like a sine wave is a wave. It goes up and down forever. So it never really settles down on a particular value on the ends, and not all functions do. We're going to limit ourselves to functions that have nice end behaviors.